All right, this is Unit 2, Lesson 12. We're going to be looking at comparing graphs, or using graphs to compare relationships. So just to get started, we're just going to fresh back to multiplying and dividing fractions. So remember, when we're multiplying fractions, you just multiply the numerators together and the denominators together. So 2 times 1 equals 2. 3 times 2 is 6. And this can be reduced to 1/3. Okay, same thing. 4 times 1 is 4. 3 times 4 is 12. This is going to also equal 1/3. Okay, now when we divide fractions, so remember the keep, change, flip. You keep the first term, flip the fraction, and you're changing division to multiplication. So this becomes 4 times 5 over 1, which is really the same as just 4 times 5, which equals 20. Okay, likewise with this one, you have 9/6. We're going to change division to multiplication, and then we're going to flip that fraction 2 over 1, which once again is just like multiplying it by 2. So 9 times 2 equals 18. 6 times 1 is 6. That reduces to 3. All right. So now let's look at 12.2. So the race to the bumper cars. It says here Diego, Lynn, and Maya went from the ticket booth to the bumper cars. Okay, and it said use each description to complete the table representing the person's journey. Diego left the ticket booth at the same time as Tyler. Diego jogged ahead at a steady pace and reached the bumper cars in 30 seconds. Lynn left the ticket booth at the same time as Tyler. She ran at a steady pace and arrived at the bumper cars in 20 seconds. Maya left the booth 10 seconds later than Tyler. Her steady jog enabled her to catch up with Tyler just as he arrived at the bumper cars. Okay, so the Tyler they're referring to, that's from lesson 11, where it took him 50 seconds to get to the bumper cars. Okay, so we need to fill out these tables here. So we can find our constant of proportionality by dividing our y by our given x. So 50 divided by 30, that's going to give us 5/3, or 1 2/3. We're going to leave it as 5/3 because when we're going to multiply 15 by 5/3, we're going to be left with 25. 15 divided by 3 is 5. 5 times 5 is 25. Diego's distance at 0 is going to be 0. And then at 1 second, he's went 5.3 meters. Sorry, not 5.3. 5/3 meters. So 1 2/3 of a meter. Okay, Lynn, so same thing. We know that at 0 seconds, he went 0 meters. Okay, now to find our constant of proportionality, we take our 50 divided by 20. And this is going to equal 2.5. Okay, so now if we take 25 divided by 2.5, we'll get our time. So 25 divided by 2.5 just gives us 10. So in 10 seconds, Lynn was halfway there. Okay, so then in 1 second, Lynn goes 2.5 meters. Okay, last one. So this is Maya, now remember she started 10 seconds late. So Maya's time in this first one is going to be at 10 seconds. She's at 0. Okay. So now from 25 to 50, half of that was, or this is half of 50 is 25, so half of 40 would be 20. But that's still not correct, because there's only 30 seconds, so half of 30 would be 15. So sorry. So 10 to 40, that was 30 seconds. That had passed. Okay, so she went half the distance, or she went the full distance in 30 seconds. Now it says 40 here, but she started late. So half of 30 is 15, so add 15 seconds to 10 and you get 25 seconds. So this one is not proportional, because if you notice here, you got 10 and 0, which means that those are not, that it's not going to pass through the origin. So you can't use the usual 50 divided by 40 to get your constant of proportionality. If you did 50 divided by 40, you get 1.25. And 25 divided by 1.25 is not 25. All right, so here, in 1 second, Maya would still be at a distance of 0. Okay, because once again, this one was not going to follow that pattern of a proportional relationship. Okay, so we filled out the table. Now that we've filled out the table, we can go ahead and draw graphs for these. So I'm going to come over here to the graph. So I'm going to cheat a little bit here. Okay. All right, it says using different colors for each person, draw a graph of all 4 pupils' journey, including Tyler from the other day. Okay, so we know Tyler, he went it took him 40 seconds to go 50 miles. So, oops. So 40, 50, so we plot that point. We just draw a straight line to the origin, right? His was a proportional relationship. Okay, we'll use orange for Diego. So we know that in 30 seconds, he went 50. Okay, we'll use green for Lynn. So Lynn went 50 in 20 seconds. No, still not right. My tool doesn't want to work here. Okay, and then last, Maya, and we will denote hers in blue. So now Maya started at 10 seconds, right? So she's not going through the origin because she, at 10 seconds, she still hasn't left yet. But she reaches Tyler's time at the same time. Okay, so there we go. We've got Diego, Lynn, Tyler, and Maya. Okay. So now it says which person is moving the most quickly. How is that reflected in the graph? Okay, so Diego, nope, actually, sorry, I mixed up the names. Lynn and Diego's graphs need to be switched. Okay, Lynn is going the fastest. He went the furthest in the shortest amount of time. He was going 2.5 meters per second. And so you notice that on the graph, his line is a steeper incline. Diego's would be next. Maya's would be the same as Diego's. If you notice, they're parallel lines. They follow the same, they cover the same distance in the same amount of time. Maya just started that 10 seconds later. And then Tyler's original, that was the slowest. That slope is isn't as steep as all the others. So, the steeper the graph, or the steeper the line, so the steeper the line, the faster the person went. Okay. All right, so let's refer back to number 3. Oh, sorry, we already answered number 3. Now it says, are you ready for more? It says, write an equation to represent each person's relationship between time and distance. So remember, our equations are going to be in the form y equals k times x. So for Lynn, our y is equal to 2.5 times x. This would be Lynn. So for Diego, y is equal to 5/3 x. So this is Diego. Okay, Tyler went at a speed of 1.25. So Tyler was y equals 1.25x. And then Maya's is not going to be a proportional relationship. So she still has the y in relation to x, but she's going to have that time delay. So y equals, and her speed was the same as Diego's of 5/3. However, she had a minus 10. Okay, because when x equals, when x equaled 40, she'd gone 50. But you have to minus the 10 seconds from the beginning. So, once again, this isn't a proportional relationship because you have added that minus 10. Okay. Last 2 graphs to look at. Okay, it says meteoroid Perseid 245 and asteroid X travel through the solar system. The graph shows the distance each traveled after a given point in time. Okay, so asteroid X is the blue line. Perseid 245 is the black line. So it just asks, is asteroid X traveling faster or slower than Perseid 245? Explain how you know. So asteroid X is a steeper slope. It rises quicker. Therefore, asteroid X is traveling faster. So steeper slope goes higher in a shorter amount of time. Okay, so once again, on a graph that, if they're both proportional, the one that it has a steeper slope means they're going faster, or it is increasing quicker. Okay, the next two graphs, it says the graph shows the price P of different lengths, L, of two types of rope. If you buy $1 of each kind of rope, which one will be longer? Okay, so let's just say right here is $1. Okay, and so if we connect this line, you get points right here. So when this one comes down, and on a number line, the further right you go, the bigger the number. So you will get a longer nylon rope for $1 than you would cotton. Okay, and just by looking at the graph, you can see that when for that $1 price, you have a longer length, you get almost double the amount of nylon rope compared to the cotton rope. So think about this when you're kind of thinking backwards now. It's not the one that's the steepest. Well, the one that's the steepest costs the most. And usually if something costs more, you get less for the same price as something that is cheaper. All right, that is Unit 12. So that's just looking at graphs and kind of comparing them, noticing some things about kind of their slope and what that relates to. Costs more, going faster, vice versa, and just how we can use that to compare different graphs, even on ones that aren't labeled on the sides, other than our price and length.